Right, hello, and welcome to another Dauntless development video. I'm Liam again. So this is the second episode in the second video in the C# beginner tutorial video series. So last time we set up Visual Studio and we set up this little hello world program, and we used a little variable, a string variable here, in order to store this string and then write it to the console. So if you haven't seen that already, I recommend checking it out because it'll get you up to speed. And this time we're going to be looking a bit more in depth at how variables work and kind of a little bit why they're used. And so I've got a little table here provided. So I'll put this in the description so that if you want to look at it again in the future, this isn't an exhaustive list of all variables. This is just some of the most common. I've realized that I don't have string on this table when I made it, but string is also a common one as we used it, as I'm pretty sure you're aware since we used it already. So when I put this in the description, I'll add it. But in the meantime, this is what we've got. And we don't, as I said, this is not an exhaustive list. There's still more that exist. I wouldn't have been able to fit them all in one screen. But these are just some of the most common. So you've got a bool, which is true or false. So that has two options. It can either be true or false, or 1 or 0 potentially, but it's true or false. So this is used for like an on or an off state, or you can use it to find, like, basically, I mean, if you're using it in a game, it could be like is alive, and then if it's true, then they are alive. If it's false, then they're not alive. And that takes up 8 bits. So if you look at the table, you can see that on the left column, I've got the variable name. In the middle column, I have description of the variable. And on the right column, I have the size in bits. So bits is just kind of how the amount of memory used is measured. That's how it's quantified. So you've got 8 bits in a byte. So that bool is 1 byte. So like if you think of like internet speed, if you're not sure on like bits and bytes, internet speed's often measured in bits, like megabits per second or gigabit. And then you might also see like megabytes. So basically there's just anytime you see byte, it's 8 bits. So to convert between them, you just multiply your bytes by 8 to get the bits, or divide by 8 to get from bits to bytes. But yeah, that's just how kind of memory's measured. So yeah, you've got a bool, which is true or false, and it only uses 1 byte or 8 bits. An int, which is an integer, so it's a positive or a negative whole number. It can be a positive or a negative number, but it can't have any decimal places. It's 32 bits. You've got a long, which is a long integer, so it's a positive or a negative long integer, so it has a greater range of values. As you can see, it's 64 bits, so since it takes up twice as much space, you can imagine it can have twice as many potential numbers like stored. Well, not necessarily twice as many numbers, but the number can be twice as large. So yeah, we've got a float, which is a single precision floating point number. So all that means is it has a decimal place. So that's 32 bits. You've got a double precision floating point number, which is 64 bits. So that's kind of like the long, in that it's just an expanded version of the float. So it can store a greater range of values, or more specifically, more precise values. So it can have more decimal places, hence why it's called double precision. So it can have more decimal places, means you can get closer to the exact value that you want. You've got char, which is a single character. So anything on your keyboard represents a char, basically. So like any of the letters, numbers, or symbols, they're all chars. So char just means character. uint is a unsigned integer, so that's 32 bits, and that means it can be only positive, so it's just a positive number, positive whole number. And the reason to use this is if you're using, like, say, one example would be like the magnitude, like the distance between 2 points. Obviously the distance is never going to be a negative number. You can't be negative 5 meters away from something. You are either 5 meters away. Distance doesn't necessarily have direction. So if you're just needing the magnitude for something, this means that you can have a greater range of values without needing to go to a long necessarily. You can use it in the same amount of space. And then you've got a u long, which is an unsigned long, which is the same thing, except it's just a long this time. So it's 64 bits instead of 32. So you can have a greater range of values, and because of it being only positive, even greater again. And finally on this list, as I said, this is not an exhaustive list at all. You've got var, which all var is an adaptable variable. So it basically, it'll adapt to whatever value is given. So as you can see, I give an example there. Var a equals 1 would be the same as int a equals 1, because it would see that 1, that it's an integer, and when it sees that 1 is an integer, it will say, okay, a must be an integer then, and it'll just mean that a is an integer. So this is kind of, the compiler kind of figures out what it should be. Now this is quite useful. You don't see this in all languages, but it's most of the time it's safer to declare outright which variable type it is, just to avoid mistakes. But there are definitely cases where var is just the simplest thing to do. As I said, I'll put that in the description. So what we've got is, right here, we have declared a variable called string. Oh, sorry, not called string. A variable of type string called line. And that line variable is equivalent to this string here. Now, as I said, string's not in that table, but yeah, string is one of the common variables. So what we can do is we can say, we can have this string here, and as we every time we declare a variable, every time we first use the variable, so the very first time, we don't necessarily need to assign the value straight away. So what we can do is we can say, I can put a semicolon there because we need to put semicolon, and then line equals. So as I said last time, semicolons are like a full stop at the end of a sentence. It's just like, it's a way of telling the compiler that I am finished with this line. So we've got this string called line. So all we do here is we declare it. We don't say what it is. We just say we have a string. And all we're doing when we declare this variable is we're saying we are going to make a string that has a string amount of memory. So the amount of memory that's used by that. Same as, for example, if we have an int, so int a. If we do this, the compiler sets aside a block of memory that's an integer size. So if we look back at the table that we have, integer is 32 bits. So when the compiler sees this, it says, okay, I'm going to find some memory that is 32 bits wide. If you think of it like just like kind of on a meter, it finds like 32 bits of space. And it says, okay, I'm going to label that 32 bits of space A. And then anytime it wants to find out what's inside that 32 bits of space, it looks for A, and then it finds the label that it's given it called A, and it goes there. So it's kind of like a bookmark. But yeah. So that's that. Okay, so yeah, you can use this this int a as part of the string if you want. So if you assign a value to it, so say 5, what you can do is you can then say plus a. Now what this will do is this will say write the string. So what goes into here is a string, and we'll cover kind of, because this is a function, we'll cover that in a bit more depth in a few videos down the line. But what we're doing here is when you're adding strings together, it doesn't like, say, like if you think of like in maths, when you use this plus symbol, you would be like adding a number to it. All we're doing here is saying append it, so add it to the end. So we add this A to the end of this string. So this just treats this A like it was part of a string. So it'll just put a 5 at the end. Since it won't actually use A, it'll use the value that it represents. So then when we say Control F5 and we run this, you can see it says, hello, this is my text 5. And then this is new text because we only put the plus A on the first one. It doesn't modify this string. It just modifies what's output here. Now what we could do, if we did want to modify the string, even though we override it here anyway, so it wouldn't matter, but if we did want to override the string, we can say plus 5, plus A. And then that, when we hit Control F5, we'll do the same thing basically. So we don't have to necessarily do it in those brackets. We can do it here, but that's what happens when you add an int to a string anyway. Now, that's kind of all we're going to cover today, or right now anyway. But next time, I'm going to cover some of the operators, so like how to assign values properly, because we've not really talked about that. We've just kind of done it. And I'm going to look at if statements, which are one of the most important things in code altogether. Like if statements are what drives all decisions made by a program, and you'll see them in every programming language. I'm yet to hear of a programming language that doesn't include an if statement of some variety. It might not necessarily be called if statement, but it will perform like that. But yes, that's all for now, and I'll see you next time.